Alright guys, let's go ahead and start. Sorry if I'm not being too loud here. There is some other alternate noises, but hopefully they won't distract us here. Alright guys, quiz 3, continuity 1. Determine if f is continuous or discontinuous where x equals 1. If f is discontinuous at that point, indicate the type of discontinuity. So I go to x equals 1, and I can see that at 1 it's a nice solid line, so it's continuous. If they were to ask me at negative 3, this one right here would have been a removable. They didn't ask that, but I'm just going and stating that. If they would have asked at x equals 0, that would have been a jump. If they would have asked at x equals 3, that would have been removable. And if they would have asked at x equals 4, that would have been an infinite discontinuity. All right, let's continue, guys. Question 2, the graph of the function is given below. Which of the following intervals is f continuous? So notice the brackets and parentheses, guys. So 3 to 5 with a bracket. Well, to the right side of this 3, you can't be a bracket. It has to be a parenthesis. So that one's done. Negative 1 to 3. Negative 1. Nope, you have a removable discontinuity there, so it has to be a parenthesis. 5 to 8, the 5 to 8, no, the 5 has to be a bracket because there's a removable there. I mean, it has to be a parenthesis, sorry. And you have a bracket, so that one's done. And then 3 to 5, parenthesis, yeah, because you'll never reach the 3 here. This goes down forever. So that is correct. So there it is. You're continuous from 3 to 5, not including 3, not including 5. So that's your answer. All right, next one, guys. Determine if the function f of x equals square root of x squared plus 16 is continuous at the point where x equals 4. Yes. Look, without even doing anything, guys, you have x squared plus 16. That is always greater than or equal to 0. So this will always be continuous no matter what. So letter B. Question 4. Determine if the function 1 minus x squared. Notice it's not even a rational here. Absolute value of that is continuous at the point where x equals negative 1. Well, it's continuous everywhere. There is not a single x value that would make this discontinuous or make this not exist. So the function is continuous at negative 1. Determine if the function negative 4x squared plus 9, this function here, 2 when it's like negative 3, x cubed for x greater than negative 3, it's continuous where x equals negative 3. Well, let's find out. So negative 4, I'm doing the left side first, times negative 3 squared plus 9. So let's see, negative 4 times negative 3 squared is 9 plus 9. So negative 4 times 9, that's a negative 36 plus 9. And so I see a negative 27. All right, that's from the left. That's from the left. Now let me do from the right. Negative 3 to the third power is just negative 27. Okay, so the limit definitely exists, but are you continuous at negative 3? Well, notice that y value is not negative 27. That's just 2. So no, you're not continuous. You have a removable discontinuity. Now, how do you know you have a removable discontinuity? Because both y values approach the same, they converge at the same y value, guys. So that's how I know I have a hole. If you want to know more or less how that looks, here's a rough sketch. It doesn't look exactly like this, but here's a rough sketch. It looks something like hole and then something like that. At a negative 3, you have a point 2, like that. All right. Determine if the function is continuous at the point where x equals 4. All right. So you can't equal 4 because you have a 0 in the denominator. Expand this, guys. X minus 4 or x plus 4. All over x minus 4. X minus 4's cancel out. So now you can see 4 plus 4 is 8. Now notice 4, 8. So it plugs in that hole. You have a hole at 4, 8. Only for the top one. But then for this one, x equals 4 equals 8, that's a 0.48. And it plugs in that hole, guys. So you're continuous. Next one. Classify discontinuities, if any, for the given function. Let's see. So at 1, I have 3 times 1 minus 2, which is 1. To the right, 1 over 1 squared, which is 1. And do I plug in that hole? It looks like you don't. So you have a removable discontinuity. I can already see some of you guys are asking, Chavez, how do you know? I need a visual. All right, let's give you a visual. Relax, guys. 3x minus 2 is just a linear line. So here's my linear line. Let's see, 1. So I'm going to say here's 1. And it's a linear line with y-intercept negative 2. So there it is, negative 2. And then I have a point at 1, 0. This is blue. I'm going to say this guy's red. So 1, 0, here's my point. And I'm going to say this guy's green. So then I look something like there. Now we're all happy. As you can see, you have a removable discontinuity, guys. All right, let's go to the next one. So this one, let's see. Let me draw a grid first, guys. Let's see, 0, 1, 2. All right. To the left of 0, it's always 7. So I'm going to say 7's right here. That's 7. Between 0 and 1, I look like x squared. So I'm going to count this as red. So 0 whole, and it's a little curve, a parabola until you get to 1, and that y value is at 1. Between 1 and 2, I'm going to use blue for this one. It's always 1. So I plug in this hole, and I go all the way to 2 and on a hole. And then for everything greater than 2, I just look like the value of x. So if x is 2, that means the y value is 2. So solid because it has an equal sign. And just a linear line. There it is. Jump at 0. Jump. And another jump at 2. The function f of x equals x squared minus 4x is defined everywhere except negative 1. That's duh because you can't plug in a negative 1. So they want you to define a negative 1 so it's continuous. So factor it out, guys. Let's see. X minus 5x plus 1 over x plus 1. Notice they cancel out. So now that they canceled out, my limit f of negative 1, negative 1 minus 5 is negative 6. So if you just put a point, negative 1 comma negative 6, you'll be continuous. The function f of x equals 1 over x plus 1 is defined everywhere except negative 1. If possible, define f of x at negative 1 so it becomes continuous at negative 1. Not possible, guys. Look at the function. 1 over x plus 1 looks like this. Here's negative 1, and you have... That's a vertical asymptote there. And you look something like this. Positive infinity, you cross the y-axis at the y value of 1, and horizontal asymptote of 0. And you look something like this. So it's not possible because you have an infinite discontinuity. Alright guys, I hope we learned something. And I'll record the next one in a little bit. Alright, bye.